Hello, everyone, and welcome to the Homework 1 introduction video. Today's homework goes over, it's worth 2 points, and it's covering unit testing, specifically with the JUnit package. And so JUnit is just this really nice set of tools that we like to use for testing our Java code. And so learning how to use this is crucial to the rest of the class because we'll use it for every single coding assignment going on forward. We're also going to be installing this helpful tool called Make. I won't talk about that in this video, but just know that you're also installing another very important tool today in this homework. And again, it is important for running certain things later on in the class. So you'll want to make sure you do it correctly now. And then lastly, there are sort of 3 separate exercises in homework 1. There's arithmetic.java, compound interest.java, and multi-R or multi-array, whatever, it's short for multi-array. And so arithmetic is really, really quick. And I would say compound interest and multi-R are going to take a little bit longer. So arithmetic, basically, this is just, it's hardly even exercise. It's more just meant to show why JUnit is valuable. And so we can just check it out together right now. And so basically, we have this very simple arithmetic file right here, and it has 2 methods, product and sum. And so product is correctly, we think it's working, and sum, for whatever reason, is wrong. I don't know why, but it's wrong. And so we can imagine that if arithmetic was actually a much more complicated class, it could actually be harder to find the bug. And so in cases like this, it's important that we have tests to make sure that our methods are working, so that we know that our code was written correctly, right? Because you can't always just look at the method and tell that it's wrong. And so what happens if we try to test our code without JUnit? Well, we have to write all sorts of methods. For example, this report method, which is, printing out the results, approx equal, check, test product to sum, whatever. It's really messy looking. It's super complicated. And we had to define all these methods, right? And that's super annoying. And someone else has already done the work for us. And so what we can actually do is go to JUnit test. You're going to notice this one is much shorter. It only defines the necessary tests, and the methods for sort of making sure that things are as they expect are actually already implemented by the JUnit package. And so here we have test product, right? And so it uses this assert equals method from JUnit, which says that we expect the result to be 30. And what we actually get is going to be the result of our code, right? So arithmetic.product of 5 and 6. And so here we expect 30. If we do 5 and -6, we expect -30, right? And if we do 0 and -6, we expect 0. And so this is testing whether product works correctly. You're going to notice this third argument, delta. And so delta is sort of just this threshold for how wrong we can be, right? And you can imagine that, let's say the correct answer is 6, but our multiplication worked out and we got 5.999999999, right? If you want that to be counted as correct in your tests, you don't want 5.999 to get marked as wrong when 6 was the correct answer. You should specify a non-zero delta, or in other words, a non-zero tolerance for error or wiggle room. And so that's what this delta argument is. And we just defined it to be a really small number here. That's how test product works. And then we have test sum. And so this is, again, just making sure that our addition works correctly, right? And so now what happens if we run this tests? You're going to see we get this super descriptive output that tells us what exactly failed, how long it took also, and then which test failed, right? It was test sum. And on line 27, right, we got a failure because we expected 11 but got 30, right? This is super detailed. We could compare this to what we had written in arithmetic test. And if we run the non-JUnit version, all it tells us is that product is okay and sum fails. And so we wrote, so much more code here, yet the output is not even half as descriptive. And so this shows the benefit of using JUnit, which wrote all these complicated methods and did all the dirty work for you and gives you a really beautiful, clean answer. And so the last thing with arithmetic is just for you to, fix the bug. It is very complicated. This could take 10 hours to figure out what's wrong here. But yeah, that's pretty much all arithmetic is. It's mostly just to show you why it's so valuable that we use JUnit. And so now sort of moving back to the rest of the homework, we can talk about compound interest. So take a quick breath before this one. Compound interest is, I think, a little more involved just because you sort of have to understand the concepts behind it. But it is, again, mostly meant to like figure out how to write the tests, or like to exercise your ability to write tests rather than it is like write a super complicated method. So with that being started, or being stated, let's just go over the main ideas. So the first one is that when you put money in the bank will give you interest. For example, if I put $100 in my savings account this year and I have an interest rate of 5%, or as a decimal, that's 0.05, right? You move the decimal twice. Next year, I will have $105. And it's because I took that amount I had, 100, right? And then I had that amount plus 0.05 times 100, or 5, added to it. And so it's total 105 after 1 year, right? However, inflation also affects the value of our money. And so because of inflation, our money just tends to be worth less over time, which is why like back in 1980, you could buy a totally new car for $7,000. You know, you can't do that now. And so money tends to be like, I guess, worthless, or it has less buying power. And so, for example, with an inflation rate of 3% or 0.03 every year, a dollar has 97% of the buying power it had the year before. Thus, going back to that earlier example, if you deposited $100 this year and had an interest rate of 5%, but an inflation rate of 3%, next year, the raw number of dollars you have will still be 105, just like earlier, right? We have $105 in the bank. However, that $105 next year is only going to be worth 97% of what it's worth this year. Or in other words, right, because 100 minus 3% gives you 97%. And so when you multiply that, it works out that your money actually has the equivalent buying power of $101.85, right? And so the key idea here that I want everyone to make sure they understand is you are going to have $105, right? The amount of money in your bank account is not affected by inflation. However, it's just able to buy less. And so it is equivalent to how much $101.85 could buy today. So take a moment, soak that in. If you did not understand it, maybe ask on Piazza, or just like make sure you understand these core ideas before we start moving on. And the point of compound interest and this sort of assignment is to teach you the importance of test-driven development, or TTD. Basically, you need to write the tests before you write the code. You absolutely must write the tests before you write the code, right? And the idea here is that with TDD, we're setting the standard of what our code should be able to do before we write the code, right? It's like saying, oh, I know what my code should be able to do. I'm going to set the goal marker, and I will write my code until I reach that goal. And so it's clearly defined before, and it sort of allows you not to cheat yourself out of writing the code correctly, right? You set the standard way in advance, and you know what you have to be able to do. This is opposed to if you were to write the code first, and then afterwards go, oh, I guess I should write tests. And you sort of write tests that I guess like are biased towards like making sure the code you've already written passes, right? And so it's just really important that we write our test first. It makes sure we understand what we're doing, right? We understand the goals, and it actually gives you more clarity when you're writing the code because you know what needs to be done in order to pass your tests. So with compound interest, I'm going to explain every single method right now, but I need you to go write tests for each method before you try writing the methods. So we'll start with num years. This is, I think, more straightforward method. Basically, it returns the number of years between the target year, assumed to be in the future, and the current year, which is 2022 in the skeleton, because it is 2022. And so again, write your tests, then write this method. And so you can use that JUnit assert equals to test whether num years is working. Next, we have future value. And so this takes in the present value, then the rate or your interest rate, and then the target year. And so the idea is that given present value, which appreciates annually by rate, or in other words, has an interest rate of rate, determine the balance in the year target year, right? And so the idea is I'm putting some amount of money, present value, in the bank right now. I know I'm going to keep gaining interest, and I want to know, oh, by the time we reach 2050, how much more money do I have, right? Because you're gaining more money due to interest. And so how can we calculate this? Well, as an example, let's say it's currently 2022 and I have present value in my bank account and my interest rate is rate given as a decimal. In 2023, my balance is going to be 1 plus rate times present value, or in other words, 1 plus rate times what you had in 2022. In 2024, you're going to have everything you had in 2023 plus that 1 plus rate, right? Because you're gaining interest on what you had the year before. And if we take this 2023 balance and sort of expand it out to what we know it to be, which was 1 plus rate times present value, the 2024 balance is actually equals to this big thing that I will not attempt to say. Similarly, in 2025, you're going to get everything you had in 2024 plus that interest, right? And that expands out to this. And so maybe you're noticing some sort of pattern here, right? You have this fixed quantity and you're multiplying it a certain amount of times. And so you can use this, I think, to define a pretty compact math expression that will help you determine the future value. So I have 2 hints for you. Number 1, do you already have a method that determines the number of years between this year and the target year? And how could that be relevant? Could it maybe relate to how many times you need to multiply this thing? Just a thought. And hint number 2, use methods from the math package. And so you could reference these by doing like math.sum, math.pal, whatever. And so those are my hints for future value. Again, go write the tests, figure out some test cases or examples, and then go write the method. Now we're going to talk about future value real. And so this is just like future value, only now we have to worry about inflation. So remember, the actual amount of money you will have is not affected by inflation. Or in other words, the raw amount is the same. And do we have a method that's going to calculate that raw amount of money you will have in the target year? I repeat, do we have a method that says, ooh, if you put this present value in the bank with an inflation rate of rate, this is how much money you'll have in the target year? It'd be so nice if we had a method like that. And so once we have that raw amount of money that we'd have in the target year, or in other words, the nominal value, we just need to figure out how much less it is worth now due to inflation, right? So again, we have that raw amount of money that's not changing, but the buying power is lower because of inflation. And so we need to figure out what is its equivalent like buying power, because like money is worth less every year, right? And so in 2023, right, the money is going to be worth 1 minus inflation rate times the 2022 value, right? And again, let's think about this core idea slide, right? We said if the inflation rate is 3%, a dollar has 97% of the buying power it had before. Or in other words, we're doing 1 minus 0.03 to get 0.97, right? And so this is why here on future value real, we're doing 1 minus the inflation rate times the 2022 value, and that gives you how much it's worth in 2023. In 2024, again, we've depreciated by the inflation rate, or in other words, 1 minus inflation rate times what we had in the last year. Or we could expand this out to be 1 minus inflation rate times 1 minus inflation rate times the 2022 value. And so maybe this is looking very familiar to you, right? And this asks the question, do we have a method we've already written that could handle this? I want to give a huge hint right now, which is that in future value, we never specified that the rate had to be positive, right? So think about what happens if you give it a negative rate. Now we're going to move on to total savings. And so this is a totally different method. Basically, the idea is that you are very proactive with your money and you decide to invest per year amount of money per year, right? And so, for example, let's say per year is $100. The target year is 2024, and your interest rate is 0.05. And as always, assume this year is 2022. So at the end of this year, you will have invested $100, right? Because you're investing 100 per year. In 2023, that $100 that you invested last year is now worth, or is like now $105 thanks to interest. And also you invest another $100. So your total savings balance is 205, right? In 2024, your previous balance of 205, right, is now worth $200.15 and $215.25 thanks to interest, right? Because we took this and multiplied it by 1.05. If you wanted to, you could break this calculation instead of 205 times 1.05, you could break it up into 100 times 1.05 times 1.05 plus 100 times 1.05. And the way we think about this is, right, this is that $100 you invested in 2022. And so on that $100, you gained sort of your interest twice over, right? For the 2023 $100 that you invested, you've gained interest on that once, right? And then of course, in 2024, you're also investing another $100 because you invest 100 per year. And so your total savings balance is $315.25 because you have the amount from before plus your new investment of $100. And again, you might be noticing some sort of pattern here, right? Where you invest and then you sort of take that amount and it's worth more thanks to interest. And I want to give sort of a hint here, which is that in future value, we were able to generalize this relationship into a simple one-line math expression. Or not necessarily one line, but like quite simple, right? For total savings, it's not possible to create this short math equation that describes the amount of money we'll have in the future. Sorry, I meant to say in the future, not 2022. And so as a huge hint, the staff solution uses a loop to solve total savings. If you're stuck, I recommend trying that. And now we're going to talk about total savings real. And so consider that there is an analogy between future value real, as total savings is to total savings real, right? And so rather than explain to you word for word what total savings real is supposed to do, I'm just going to point out that, you know, there's sort of these analogous relationships, and I think you can figure out what to do in total savings real based on how you handled future value real. Lastly, for compound interest, we have these two methods, print dollar future value and print savings future value. And so you just have to edit these two methods to call the methods you've already written, right? And so again, you wrote all these methods, right? So you just call them from these and they're going to print out some interesting facts. So who knew that CS61B would also teach you about personal finance? I really don't know much, but I guess what I know is in this homework assignment. But yeah, print dollar future value and print savings future value should not be complicated or like writing new code really. It's more just like editing it slightly to call things you've already written. So that was compound interest. Feel free to take a break if you need it, and we will move on to multidimensional arrays. So we're going to talk about 2D arrays. It might sound very complicated, right? Like multidimensional array sounds very fancy, but it's pretty straightforward, I think. So a variable of type int array named R might look something like this, right? 1, 2, 3. Well, we could also make an int array, or in other words, an array where each element is an int array, so an array of int arrays, that could look like this, right? And so here we can see we have this sort of outer array, and each element in this outer array is another int array. And so these inner arrays have numbers. And so I sort of think of it as like remembering how to do the syntax for this, the type. When you have an int array, you have the type that is inside plus the brackets. So when you have a 2D array or a nested array, the type that the outer array holds is int array, right? And then the inner array's type that it holds is int. And so I think it kind of makes sense to have this like variable type look like that, right? And so now the question is, what are the dimensions of this 2D array? Take a moment, pause the video, think about it. And so one way we can describe this, we could, we'll often say that this outer array has like 3 rows and 4 columns, right? Or we could also say the outer array has length 3 and each inner array has length 4. The inner arrays could also potentially be of different sizes, right? Nothing's dictating that they all have to be the same necessarily. I want to point out there are going to be cases where you'd want them all to be the same, right? And you can enforce that. But like just by their nature, they don't have to be the same, right? And so we could have something like this where the first inner array has 3 ints, the second one has 2, and the last one has 4. And so multi-R, this class that's in the skeleton, is a simple class for working with these multidimensional int arrays. We say multidimensional to make it sound fancy, but in reality, we're just doing 2D, right? And so there are 3 methods in the skeleton. Only 2 of them are mandatory, but one of them is very helpful for debugging. And so as always, you need to write the tests for multi-R's methods before actually writing the methods, right? We are setting the standard by writing our tests, and then we'll write the code to meet our standards. And so when writing the tests, you're going to need to define test inputs, right? If you're going to use assert equals or call the methods, you might want to have the actual like 2D arrays to put into the methods, right? And so the syntax for declaring and instantiating a normal int array and a 2D int array is as follows. For the regular or normal like 1D array, if you wanted to put it with the elements 1, 2, and 3, you could do something like this, right? If you wanted an array but make it 2D, then you could do something like this, right? And so you instantiate it and sort of populate the array with this format. And so we can see this one again happens to have 3 inner arrays, and then those inner arrays have the elements 1, 2, then 3, 4, 5, 6, and then 7, 8 respectively. And so you might also find the JUnit method assert array equals to be useful. You also might not. I think for this particular homework assignment, you actually might not need it for your tests, but in the future, it's always helpful to know about this method. So one of the methods that you have to do in multi-array, return the maximum value in the entire multi-array, right? So for example, the following multi-array would have a max value of, I wrote 33, but I meant to say 31, just because if we do a quick scan over this, we see the biggest element in the entire 2D array is 31, right? Sorry about my boo-boo. And so for solving max value, if you're stuck, consider these hints. Number 1, how would you write max for a 1D array, right? If you don't know how to do this, you should watch the homework 0 solution walkthrough, because I did indeed walk through how to do that. And so first, just focus on how you do it for a 1D array, and then try to make that structure apply to a 2D array. And maybe a nested array calls for a nested for loop, right? So that's one thing that I will leave with you. The other method that you have to do in multi-array is all row sums. And so in this one, you're going to return an int array where each item is the sum of the corresponding row in the input R, right? So for example, let's say we have this multi-array, right? If we did all row sums on this, what we would get is this output. And we'll see why. It's because the first row or the first int array in our multi-array has the sum 1 plus 20 plus 7 plus 5, which is 33. The second one is 4 plus 9 plus 0 minus 3, which is 10. And then 31 plus 1 plus 10 plus 11, which is 53. Unless I did my math wrong, because, I'm not very good at addition. It can be very hard for me. But basically, each row has a sum or like a corresponding sum in the output. And so we can see the output is this 33, 10, 53. And so this is the problem you have to do. On the next slide, I'll show some hints, but I recommend attempting it first. So if you are really stuck, check out this nested for loop structure. You can just read it yourself. I will just give you a hint that doing something like this, although with the parentheses correctly there, right, is probably going to be a part of your solution. And the idea is that this outer for loop looped to the outer array, and this inner loop loops through each inner array, right? The last thing I want you to consider also is, how do we know the size of the output, right? Well, it's the number of rows, right? Or in other words, the number of elements in the outer array, or r.length, right? And so this quantity basically is the number of items our output array should have, right? Because we're going to have one item per row. And then this is just the length of the inner arrays. And so with that, that is the end of this homework 1 walkthrough video. I hope that you have a wonderful day, drink water, and update your, do the software update that you've been putting off, and change your sheets. Okay, goodbye.